In this video, we're going to look at the solutions to the Chapter 8 quiz review. So for the first few problems, the first thing I'm going to do is identify what type of triangle it is so that I'll know what strategy to use in finding the missing pieces. So for triangle 1, it's an SAS triangle. We're given two sides and the angle in between, which tells me I'm going to use the law of cosines. So I'm going to use the law of cosines to find side A, which is across from the 85-degree angle. So the first thing I'm going to do is write the standard form of the law of cosines, where A is the side I'm looking for is going to be by itself. So A squared equals the other two sides, B squared plus C squared, minus 2 times BC cosine of A. You'll know if you have this set up right because to find A, I should have both B, C, and the angle A, which I do in this case. So what I'm going to do is just put the information in that I have. So A squared is going to be 22 squared plus 31 squared minus 2 times 22 times 31 cosine of 85 degrees. And what I would do is use the advantage of having a calculator, and I'm just going to put this long string of arithmetic in and find a value for A squared. If you want to write another few steps of actually multiplying this stuff out and writing that's fine, but I'm going to go straight to this. So 22 squared plus 31 squared minus 2 times 22 times 31 cosine of 85 should be 1326.119567. And I'm going to advise you to not round that here, but keep it in your calculator unrounded and always round at the very end. We want to make our answer rounded, but not round with steps in between the beginning and finding the solution. So I'm going to take the square root of that whole number that's in my calculator. And what I should get for A is 36.416. And I'm going to go to 3 decimal places for this. Now that I have side A, I'm also going to use the law of cosines to finish this problem, and I'm going to find one of my other two angles. It doesn't matter if you do angle B or angle C, but I'm going to set up a law of cosines to find angle B. And for me, I like to organize my information by making a little chart of all the angles and all the sides. That way I know I'm finding all the information I'm looking for. You don't have to do that. It's just something that is an easy way to organize your information. So I'm going to set up a law of cosines for angle B. Just filling in the table, I found my third side, so I have that. And let's proceed with finding angle B. So the alternate form of the law of cosines would be cosine of B equals A squared plus C squared minus B squared all over 2AC. And I know A, B, and C, so I can find this. So 36.416 squared, which is the side I just found, plus 31 squared minus 22 squared all over 2 times 36.416 times 31. And then putting all that in my calculator, one thing I do want to have you do is put the entire numerator in its own set of parentheses divided by the entire denominator. That way you make sure you don't have any arithmetic or order of operation issues. So what I should get is 0.7986231929. I wrote the whole decimal there. You wouldn't even have to write that. You could just take the inverse cosine of that. I'm just going to write it so it's clear what the number should be. So taking the inverse cosine of that long decimal, I should get 37.001 for angle B. So now I have all three sides and two angles. The easiest way to find your third angle is just use the fact that all three angles should add up to 180. So 180 minus 85 minus 37.001 should give me angle C, which means angle C should be 57.999 degrees. So I have all three angles and all three sides for example 1. Take a look at example 2. We're given all three sides of the triangle and asked to find the three remaining parts, which would be the three angles. So this is side, 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 which tells me I'm going to use the law of cosines again. And I'm going to use the alternate form of the law of cosines because I'm looking for an angle. So the first thing I would do is I'm going to make a little chart here to kind of organize all my information. So I know all three sides, so I'm going to fill those in. And then to find an angle, you could choose to find A, B, or C first. It won't matter. I'm going to use the alternate form of the law of cosines. So cosine of A should be B squared plus C squared minus A squared all over 2 times B times C, which, using what A, B, and C are, I would have 18 squared plus 17 squared minus 16 squared all over 2 times 18 times 17. So to find the angle, I would take the inverse cosine of that large fraction there. So I'm going to rewrite it. You don't have to rewrite it. You can use the fact that you can just plug all that in your calculator. So if I take the inverse cosine of that large fraction, one thing I do want, again, be sure to do is put the entire numerator in its own set of parentheses and the entire denominator in its own set of parentheses and divide those. So what you should get for angle A is 54.315. So I have one angle. To find a second angle, I would need to do the law of cosines again. My advice would be to finish the entire problem with the law of cosines. That way you don't have to worry about any ambiguous cases using the law of sines with where we're at now in the problem. So I'm going to set up a law of cosines again. So I'm going to find angle B. So cosine of B is going to be 16 squared plus 17 squared minus 18 squared over 2 times 16 times 17. So to find angle B, I would take the inverse cosine of that large fraction there. So the inverse cosine, I'm going to put the entire top in its own set of parentheses and the entire bottom in its own set of parentheses. And what you should get for angle B is 66.031 degrees. And then once I have two angles in a triangle, the easiest way to find the third one is add up those two angles and subtract it from 180, or take 180 degrees and subtract both of the angles that you have. So 180 minus 54.315 minus 66.031. Angle C should be 59.654. So I have found the three angles that I was looking for using the law of cosines twice, and then using the fact that all three angles add to 180 to find the third angle. So for example 3, I'm going to determine what type of triangle I have at first. So looking at the triangle here, what we have is an given information of ASA, which tells me I'm going to use the law of sines. And because it's ASA, I won't have to check for the ambiguous case. I'll just be able to set up the law of sines. One of the reasons we know we won't have the ambiguous case here is if I have two angles, there's only one answer for that third angle. It's not like I have to check two different angles that could potentially make two separate triangles. So I'll make my chart here for all three angles and all three sides and fill in what I know. So I know angle A, I know angle C, and side B. So the first thing I'm going to find is the third angle, which, again, if all three angles add up to 180, angle B's got to be 100. And once I know angle B, I'm going to use the law of sines twice to find my missing two sides. So my setup would be sine of 30 over A equals sine of 100 over 44. This setup is going to help me find side A. So cross multiply or clear fractions, however you like to think about solving this problem, I would get A sine of 100 equals 44 sine of 30. So to solve for A, I would divide both sides by sine of 100. And then putting that in my calculator, I should get A equal to 22.339. So I have side A. And here, just pause for a second. Because this is a non-right triangle, you cannot use the Pythagorean theorem to find the third side. Just know that that only works in right triangles. So to find that third side, I would need to do a law of sines again. So what I'm going to do is sine of 100 over 44 equals sine of 50 over side C, which I don't know. So cross multiplying or clearing fractions, I should get C sine of 100 equals 44 sine of 50. To solve for C, I would divide both sides by sine of 100, which should give me a C value of 34.226. And I have all 6 pieces of my triangle, all 3 angles and all 3 sides, using the law of sines twice. For example 4, take a look at the triangle so I can identify what type it is. I have 2 sides and an angle that is not in between the 2 sides. So this triangle is SSA, which tells me I'm going to use the law of sines to solve it. And also, because it's SSA, I will have to check for the ambiguous case. Make sure that there isn't more than one triangle that works, and if there is, that I'm finding all the appropriate information for both triangles. So the first thing I would do is set up the law of sines to find angle C. So setup would be sine of 30 degrees over 5 equals sine of C over 8. Multiplying both sides by 8, I would get 8 sine of 30 over 5 equals sine of C. So to find angle C, I would take the inverse sine of 8 sine of 30 over 5, and I should get 53.130 degrees for C. And again, because this was SSA, I do have to check if there is another angle for C that has the same sine value that would be a viable option for a second triangle. So the way you do that is by subtracting 53.130 degrees from 180. And what we have to do is check if 126.870 is also a possibility for angle C. And the way you check is, I'm going to try and sketch a second triangle and see if this angle, 126, would make sense. So I'm going to draw the exact same triangle. Just notice C in my original triangle, not that it's always drawn to scale, is an acute angle, which is 53.130. And because I know that 126.870 is a second option, I just drew my triangle slightly differently, showing C to be greater than 90 degrees. You don't have to. You can draw the exact same triangle. As long as you label it correctly, it won't matter. But I tried to make it look a little more to scale. So B is still 30 degrees, angle B, and angle C is now potentially 126.870. So to check if this angle for C makes sense, you would see if 126.870 plus 30 is less than 180. And because it is, that tells me that I could find an angle A that would make all three add to 180, which means there are two possible triangles in this situation, which is an example of an ambiguous case for angle C. So what I'm going to do from this point is essentially solve both triangles, find the rest of the information for both triangles, and I'm going to do that by making two separate charts. Again, that's just the way I'm choosing to organize it. You don't have to. It's just a really clean way to keep track of what we know. So if we look at our first triangle there, we have angle B is 30, and we already found angle C to be 53.130. So right away, I'm going to find angle A by subtracting 30 and 53.13 from 180, and I get 96.870. So I know all three angles in my original triangle, and I would need to find the third side, which is side A. So the way I'm going to do that is by using the law of sines. So sine of 30 over 5 equals sine of 96.870 over A. Solving for A, I'd cross multiply or clear fractions multiplying both sides by 5A. And what you should get is A sine of 30 equals 5 sine of 96.870. Dividing both sides by sine of 30, getting A by itself, I would get A to be 9.928. So finished solving that triangle with the original angle C that I found, 53.130. And then because I have two viable triangles, two possible triangles that would work here, I'm going to make a second chart for the second triangle and just fill in all that information. Some of the information, obviously the given information is exactly the same, so I'm going to label that and fill that in. And then angle C for the second triangle would be the 126.870 angle that I found earlier, which means I can find the third angle by adding 30 and 126.870 and subtracting that from 180, which tells me angle A could be 23.130. And one thing I want to point out is because I have two different answers for angle C, that'll obviously affect my angle A, because the three angles still have to add up to 180, so if C is different, then A will have to be different as well, which also means that if angle A is different, then side A should also be different in both triangles. So A in the first triangle I found was 9.928, and because A is a much smaller angle in my second triangle, it would make sense if A is a shorter side than it originally was. So let's verify that. So I would set up the law of sines to find side A. Sine of 30 over 5 equals sine of 23.130 over A. So I'd get A sine of 30 equals 5 sine of 23.130. Divide both sides by sine of 30, which tells me A would be 3.928. So when you have a triangle that is SSA, requires the law of sines, and you must check if you have more than one possible triangle that satisfies the information that we have. And in this case we did. So again, I have two separate charts for each triangle. You can just identify that you have two angle A's, two angle C's, and two side A's. Angle B, side B, and side C are the given information, should be the same. So the last few problems on the review sheet are word problems or context problems. So the first thing I'm going to do for all of these is draw a diagram and label what I know so that I can really keep track of what it is that I'm looking for. So Alice is flying her kite, and she's wondering how high it is off the ground. So I'm going to draw a little kite here. We're told that the angle of elevation, which is from where she is on the ground, and in the parentheses there at the end of the problem it says put the string on the ground. That way we have a right triangle that's basically on the ground. We're also told that there's 100 yards of string. So that would be from the ground to the kite, which in this right triangle that I drew would be the hypotenuse. And again, the angle of elevation is the angle from the ground up to the kite. So label that 38 degrees. And the question is, how high is the kite? That's what we're trying to figure out. Because this is a right triangle and we have one side of it, which is the hypotenuse, and an angle, we can use the trig functions that we've been talking about for a while now and solve for h. Don't have to use the law of sines, don't have to use the law of cosines. My setup would be sine of 38 degrees is going to be h over 100. And the reason that I would use that is h is the opposite side of 38 and 100 is the hypotenuse, and this would be a real straightforward way to find that side or the height. So multiply both sides by 100, so I get 100 sine of 38 equals h, and then putting that in my calculator, h should be 61.566 yards. I'm going to round to 3 decimal places. If the directions say 2, go to 2. If it says to the nearest yard, go to the nearest yard. Just make sure you're careful on the directions and always include units for problems where you are asked to find a measurement, a height, a distance, an angle. Make sure you include units as often as possible. So for example 6, we have a man at the top of a 200-foot building observing a car moving towards him. So what that means, at this first point on the ground, furthest away from the building, we have a car. So I'm going to draw a little car here. And the car's moving towards him. And the goal of this problem is to find out how far the car travels. And there's 2 ways I can think to show how to do this. One of them is going to involve all right triangle stuff, and the other one's going to involve some of our non-right triangle trig, and you'll see that in a second. So I'm going to kind of label everything we have. So we have a 200-foot tower, and we're told the angle of depression changes from 20 degrees to 30 degrees. So what that means is the 20-degree angle should be from horizontal where you are, so the man's on top of the building, so if you look straight out from the building, and then you measure the angle from there down to your line of sight to the object, that's an angle of depression. So 20 degrees should go there. People have a tendency to want to put it inside the triangle, and if you do that, it's going to throw off your ratio of sides, and you will definitely not get the right answer for your lengths of your triangle. So that's 20 degrees, and again, that's from the horizontal to your line of sight, looking out at the car in its first position, which is where I drew it. And then the angle of depression changes from 20 to 30 because the car is getting closer to the building. The closer you are to an object and you're looking up or down at it, the steeper the angle should be. So that's how I knew the 20-degree angle was the for the point the car is farthest away, and the 30-degree angle is for the car's second position, or the place a little bit closer to the building. We don't know how far the car traveled. That's what we're asked to find. So one thing we can say right away, if you remember back to geometry, is if you think of the ground as a horizontal line and the horizontal from the top of the building is parallel, then the lines of sight are really acting as transversals. So what I can say is that 20-degree angle of depression should be congruent to the 20-degree angle between the car and the line of sight from the car to the ground. So I can label that. And the same thing happens with the 30-degree angle of depression. I can label the bottom angles in the triangle, and that's just the fact that the 2 horizontals are parallel, getting cut by a line that forms alternate interior angles. So again, just wanted to label that. And again, like I said, there's really 2 ways to go about this. The first way is going to be all right triangle stuff. So the first thing I'm going to do is label the length of the side of the small right triangle and call it y. And the method is essentially going to be this. I'm going to try and find how far that distance is, y, so find a number for that, and then use the large right triangle, with the car's original position to the building, and find that length, and then I can subtract the total length minus the length y, and that'll give me x. So let me show you. So I'm going to use the fact that I'm dealing with a small right triangle, so tangent of 30 is the opposite side, which is 200, over the adjacent side, which is y. So then y tangent of 30 equals 200. So y should be 200 over tangent of 30, which is 346.410. So I have the length y, so I'm just going to put it right underneath there. So the second thing I'm going to do is create a variable for the entire distance from the tower to the car originally. So x plus y, x being the distance we're trying to find, and y being the distance from the car's second position to the tower. And I'm just going to call that entire length z. The only advantage to calling it z is just because it makes it easy to operate within an equation and find a value for it. So the way I'm going to use that is tangent of 20 degree being the angle where the car originally was to the tower, is 200 opposite side over the adjacent side, which is the entire length that I just called z. So if I do solve for z, I'd get z equals 200 over tangent of 20, so z is 549.495. So again, 549.495 is the total distance from the car to the building originally, and I already found y, which is the distance from the car's second position to the tower. So if I subtract those, it should give me x. So x should be 549.495 minus 346.410, which tells me x should be 203.085. Second way I'm going to approach this is going to not rely on using the right triangles the whole time. So I'm going to redraw the diagram just so I have a little bit cleaner space to work. And I'm going to label the lower two angles like I did before, 30 degrees and 20 degrees. And if you think about the small right triangle, we know that the angle from the ground to the building is 30 and forms a right triangle. The building to the ground is 90. So I have a 30, 60, 90 triangle. So if I have a 30, 60, 90 triangle, the side opposite the 30 degree angle, which is the height of the building, is the smallest leg. What that means is the hypotenuse should be 2 times the length of the small leg. So what I can say without really doing any math is the hypotenuse in this triangle should be 400. And that's just because if I have a 30, 60, 90 triangle, the hypotenuse is twice the side opposite the 30 degree angle. So now what I'm going to do is label one more angle, or label the angles in the non-right triangle. So I'm going to draw a little outline around that triangle, and I'm going to pop that little triangle out. So I'm going to be working with this triangle to find a little bit of information. So I know 20 degree angle and 150 degree angle because the 150 and the 30 should add to 180, which means that small angle up at the top should be 10. And I already found the side across from the 20 degree angle, which is the hypotenuse, to be 400. So if you look at this triangle we have now, what I can do is use the law of sines to find x. I have all three angles and I have one side, so I can find another side using the law of sines. So what I would set up is sine of 10 degrees over x equals sine of 20 over 400. And if I solve for x, it should give me the exact same distance I found before. So multiplying both sides by 400x or cross-multiplying to clear fractions, I would get 400 sine of 10 equals x sine of 20. Divide both sides by sine of 20. So x should be 400 sine of 10 over sine of 20, which is 203.085 feet. So again, you could approach this either way. The first way made a little more sense in terms of our right triangle stuff, but you didn't necessarily need to find the entire distance from the car to the tower originally in our second method, so you can choose kind of which way you want to go about it. So for problem 7, we have from the top of the tower there's an angle of depression that's 32 degrees, and the distance from the base of the tower to the car is 250 yards. The question is, how tall is the tower? So I'm going to draw a tower here. Again, you don't have to draw anything fancy in terms of the tower. You can literally just draw a vertical line. It's up to you. And then the angle of depression is from the horizontal top of the tower to the line of sight, which is down to the car. So if that's 32 degrees, what I'm going to use that to do is say the angle down at the bottom of this triangle is also 32 degrees. And the question is, how tall is the tower? So we're told the distance from the car to the tower is 250 yards, so I'm going to label that, and I'm going to draw a little car here. And the question is, how tall is the tower? So again, this is a right triangle. We don't know two sides, so I wouldn't use the Pythagorean theorem to find that, but I do know one side, and I have h, which is opposite of my 32 degree angle, and I have 250, which is adjacent to my 250 degree, or 250 is adjacent to my 32 degree angle. So I'm going to use tangent of 32 degrees equals h over 250. I'm going to solve for h by multiplying both sides by 250. And I get 250 tangent 32 should be the height of the tower. So the tower is 156.217 yards. And for the last example, example 8, we have Susie measuring an angle of elevation to the top of the Washington Monument at 40 degrees. She walks 195 feet closer to the monument and measured a new angle of 50 degrees. So the diagram is going to be similar to problem 6. So I'm going to draw something like a Washington Monument here. Looks something like that. And we have 2 different angles of elevation, one at 40, one at 50. So the spot farther away from the monument should be the smaller angle, 40 degrees, and the spot closer to the monument should be 50 degrees. And we're told that Susie walked 195 feet from one spot to the other. So the 195 feet goes right there between the distance between where she originally looked up to the tower and where she looked up to the tower the second time. So now the question is, how tall is the tower? So we're really asked to find the height here. So there's a couple ways you can go about it. I'm going to approach this similarly to the second method in example 6. So I'm going to label the rest of the angles in the non-right triangle, which is 130 degrees is supplementary to 50, and that means the small angle up at the top of the triangle is 10. So the first thing I'm going to do is, if I can find the side, which is B in this, I labeled it B, which is the hypotenuse of the small right triangle, I'll then be able to use a trig function in the small triangle to find the height. So how am I going to find B? I'm going to use the law of sines to find side B. So I do sine of 40 degrees over B equals sine of 10 degrees over 195. So that setup will let me find side B. And once I have that, I'll use that in my small triangle, because B is the hypotenuse of that smaller triangle, to find the height. So solving for B, I'd get B sine of 10 equals 195 sine of 40 degrees. Divide both sides by sine of 10. So B equals 195 sine of 40 over sine of 10. And B is 721.825 feet. So I'm just going to label that there. And again, finding that side in the non-right triangle is the same side that's the hypotenuse of the right triangle. So now if I'm in the right triangle, what I have is H is opposite of my 50 degree angle. B, which is 721.825, is the hypotenuse of that right triangle. So the trig function I would use is sine. So I'd have sine of 50 equals H over 721.825. And to solve for the height, or solve for H, I would multiply both sides by 721.825. So H should be 552.950 feet.